Hello everyone. So in today's video we are going to talk about the KNN algorithm, which is the K nearest neighbors algorithm. So we are going to see the prerequisites, introduction, sample code, and advantages and disadvantages. So prerequisites are of course Python, which is going to be a prerequisite in each and every video, since Scikit-learn library is a Python based library. And pre-processing techniques. Now inside machine learning, when you're learning the algorithms, you should also be aware of pre-processing, since most of the time pre-processing is what takes up most of the hard work or the time. So pre-processing techniques is a prerequisite for this. And good to know is of course pandas, numpy, scipy, and matplotlib, which will be a good to know in each and every video. Now introduction. So what K nearest neighbor is, it's one of the simplest machine learning algorithms, and it is based on supervised learning. So it is also called as lazy learner algorithm. What lazy learner, why it is called is because it doesn't really do anything in training, and it just stores the data and it just runs it on the go. So that's why it's called as lazy learner algorithm. So it uses Euclidean distance or Manhattan distance, both of which will be talked about later on. So it can be used for both continuous and categorical values. Now KNN is definitely like used for categorical values, but it improves the accuracy of model if you encode these values. So that is one of the main reasons why you require pre-processing, where you'll have to encode these categorical values. And you also have to make sure that you are encoding it properly, because the distance is what matters. So for example, if there is something like good, better, best, so good can be 1, better can be 2, best can be encoded as 3. So that way there is a major difference between good and the best. So the distance is what matters when you're encoding. Now KNN can also be used to replace missing values. So whenever you have a missing values in the data set, you can use the KNN algorithm to fill in this missing values using this algorithm, and it can be used for both classification and regression. So let us see what Euclidean distance is. So Euclidean distance is basically, you can see the formula over there. It takes the square root of squares and the difference. So that is the Euclidean distance, and Manhattan distance is nothing but the absolute distance between the two numbers. And when you are using KNN, you have to choose an n space. You have to think about it in an n dimensional space. Now for example, if you see a graph has x and y axis, so you can plot the 2 points. You can see you can just plot the x axis here, y axis here, and based on that you can plot the points. Now when you have more than two features, that is somewhere you will use a different dimension. You have to think about n dimensions. N can be any number, that is the number of features in the data set. So similarly, in this n dimension, you're plotting each of the point based on all these features, and you are going to see where your test point lies, the point which you have to predict. And the nearest neighbors, the k nearest neighbors, the value of k is something we have to choose, and let's say if the value of k is 3, so we'll see which 3 points are the closest to it, and based on those 3 points we will determine what the test point should be. So that is what KNN is all about, and it can use these two distance. So we'll look at a sample code now. So before looking at the code, actually we will I'll just show you an example of what I was talking about, how you will predict in KNN algorithm, and we will also see some documentation regarding KNN. So just nearest neighbors. Okay, so let's say for example, now if you have a point here, you have a point here, if you have a point here, so I'm making it into different shapes just so you understand what I'm trying to say. So there is the point here, the stars here, the square here. Now if I have a something over here, a test point, so now I have to determine what this is going to be. So this is a very simple example, and if my k value is 3, so it's going to choose the 3 nearest neighbors. Now you can easily determine optically just by seeing that these two are the closest, and the third one may be something like this one or this one. Let's say if this one, they both are stars, so it doesn't really matter much. So now we can see that the value of k is 3. So this is 1, this is 2, and this is the third one. Now there are 2 dots and 1 star. So by kind of just consider it like a majority of vote. So from this you see the maximum is dots. So the question mark over here will also be classified as a dot. So that is what KNN is about. It is very simple algorithm, like I mentioned. It will just plot the points on an n-dimensional space, and it will choose the nearest neighbors to determine the test point. Now so it is a supervised learning, and we can talk about, let's see. So again over here if you can see, there are you know it has divided it, like let's say on this side there are mostly the dark blue dots, so you can basically use some kind of division over there. And KNN, there's a lot of varieties in KNN. There's also weighted KNN, where if whatever is more close will have more weightage. Now if the point is here, and let's say if my value of k is, okay, let's just take a dot over here, and let's just take another square here. Now if this is the point I want to determine, if the value of k is 3, once again it will see the 3 closest ones, so it would be this, this, and this. So according to the normal KNN, it will be chosen as square. But if I decide to take weighted KNN, just because this is more closer, so it is more probable that this question mark is going to be a dot, because it is really close to this question mark, and this will have a higher weightage. So again there is weighted KNN, and you can read all about it in the documentation as well. So now we can begin with the code. So this is the same file I'm working on from earlier ones, and now I just write KNN and we'll start with the code then. So this time again we'll use data sets from our sklearn library. So we'll first import from sklearn, import datasets. Now we'll take the wine dataset from sklearn library. So let's say wine equals to datasets dot load underscore wine, and let's print the features, feature underscore names. We'll also print just to see the number of features and the number of rows, we can print the shape, wine.data.shape, and let us see the first 5 rows. So we can take wine.data so while it's running, we'll just wait. And like I said, KNN also, you saw that in the documentation that there is an unsupervised model also. So sklearn has a lot to offer, and you just have to go out and explore. So now you can see that the features are, there's malic acid, there's ash, there's magnesium, so many things. So feature names, the shape, now it's 178 comma 13, which means we have 13 column names, 13 features, and 178 rows. Now while printing the first 5 rows, it's printing it this way, which is not really visually appealing. So what we can do is we can also print it as a data frame. So we'll require pandas for that. Import pandas as pd, and let's just let's put it as df equals to pd dot data frame, data equals to wine dot data, and we have to take columns equals to wine dot feature underscore names, and I think that should do it. Now we'll just see df dot head. So this will provide a better representation. So now you can just see it, 14.23. So they're all numerical values over here. Now like I said, KNN can be used for categorical values, but you need to do encoding, and these are all numerical values. However, in this, what is the kind of pre-processing that you will need? So you will have to normalize them. It is always better if you normalize all the columns, because that will help the KNN model increase its accuracy. So we'll see it okay, first we'll try without pre-processing. So I'll just write a comment without pre-processing, and now we are going to split the data into train and test. So from sklearn dot model underscore selection, we'll import train, test, and split. Now we'll just store it into variables. We'll have to split our data set. So I'll just take x train, x test, y train, and y test. So equals to train, test, split, and we have to take wine dot data, wine dot target, and we have to specify the test size. Test size, we'll keep it as 0.3, which means 30% of the data will be tested upon, and 70% of the data will be used as the model. Now we'll have to now we can generate the model. So let us just run this and try. Yes, it's working fine. Now let's say model for, let's take k equals to 5 over here first. So when we're taking k equals to 5, we'll have to first import the kneighbor classifier from sklearn. From sklearn dot neighbors, import kneighbors classifier. There you go. And now we will create the KNN classifier. So let's say KNN equals to kneighbors classifier, and the number of neighbors, which is our k value, we are taking it as 5 over here. So now we will now we'll train the model using the training set. So we had split the data over here, and now we are going to use the training model. So knn dot fit and x underscore train, y underscore train. Okay, so it is working. Now we'll also have to predict the responses. So let's just take y underscore pred and KNN dot predict x underscore test. So we are going to predict the values for our test data. So that is also working fine. Now, how will we understand the predictions? So we have to use some metrics, of course. So in this, we will just talk about accuracy. We've talked about other metrics earlier. We even talked about the confusion matrix, but over here we just see what the accuracy is. So from sklearn import metrics, and I'll print let's say accuracy metrics dot accuracy underscore score. So we're going to use y test and y print. So this will see our actual values of y, that is the y test, and the predicted values. It will compare them and give us the accuracy. So you can see the accuracy is 0.66 over here, which is nothing but 66%. So now we can, try using the k value as 7. So I'll just create a new code cell and I'll just copy paste this. Now over here we are just changing it to k equals to 7. The nearest neighbor value here will be 7. And again we'll have to copy this cell as well. So let's try for 7. Okay, so over here the accuracy is remaining the same, if you see. And or let's just change the variable name so that it will be easier for us. Let's say KNN2 and ypred2. So ypred2. Okay, so the accuracy is same over here. Now most of the times the accuracy might increase and most of the times it can also decrease. So it is a bit difficult to determine the optimal value of k, but usually the value 5 and 7 is largely used. Now let us see what happens when we do the same thing with pre-processing. So let's say from sklearn will import pre-processing, and from sklearn dot pre-processing will import min-max scaler. So like I said, it is important to normalize. Now over here if you see the accuracy was just 66%, which is not bad, but then it is not really good also, and it can be improved definitely. So scalar equals to min-max scalar. Now we are going to fit scalar dot fit, and we're going to fit our data wine dot data. So let's take a new variable and store the normalized form of this data into it. So we'll take a variable called as temp and we'll put scalar dot fit underscore transform wine dot data. Now we can also see the first 5 columns, the first 5 rows. Temp 5. So like you can see now, all of the values are between 0 to 1. So this means that our data has now been normalized, and if you see over here 0.84, 0.19, 0.57. So the lower limit is 0 and the upper limit is 1, and our data is now normalized. So now once again we will generate our model with let's say k equals to 7. We can try with that directly. So now what is going to change is we have to split the data again. We have to split it from temp. So you'll have to because earlier, now we have the all these variables over here which we are using. So over there the old data has been used to store into them. But now after our data set has changed, we also have to use a new variable and split the data again, so that this new normalized data will be stored in them. So now we are going to once again we'll write, I'll just copy it from above. So I'm going to split it over here, and instead of wine.data we have to use temp, and the target would be the same and the test size will keep it as the same. So yes, this is working. Now we'll create a KNN classifier once again, and we can directly check with this. And of course we'll have to measure the accuracy. So we can take a new variable once again. Let's say KNN3 yBread3, and over here again you have to keep it yBread3. So now you can see after pre-processing the accuracy has become 0.96, which is 96%. So it has directly risen from 0.66 to 0.96. That is a 30% increase. So our accuracy is now really good. 96% accuracy is really great, and you can implement it, you can use it into real life situations as well. So that's how you see what pre-processing is and how it makes a difference. And once again, Scikit-learn also offers these directly. So just to normalize all the columns, you just had to write, these few lines of code over here, just basically these 3 lines of code. And of course, you have to import the library. So our normalization, our pre-processing, which usually would take a bit more line of code, maybe a for loop to iterate through each and every column, is now made very easy through Scikit-learn. And you can also see by combining this pre-processing technique with our KNN algorithm has provided a very good accuracy of 96.296, and you can see it over here. So that is the kind of difference pre-processing makes, and that is the kind of things that Scikit-learn also offers. Now let us go back to our presentation. So advantages and disadvantages. Now advantages, it is simple to implement, it is easy and fast. There is no training period. The data itself is the model, since the distance between these points is determined. So the data in itself is the model. There is no, different thing that you need to train or something like that. And new data can be added anytime. So it's just like a kind of just imagine it as a matrix, and when you're adding data, all it has to do is calculate the distance with each points from that data point. So that is what it does. Now the disadvantages. So feature scaling or normalization is required. The example which we saw, now without normalization we got accuracy of 0.66, but with normalization it was increased and it became 0.96. So normalization is required because no one desires an accuracy that low of around 66%, and it does not work well with large data sets. Now this algorithm, what it does is it generates the distance from one point to all the other corresponding points. Now when you have a large data set, especially with more features and even more rows, so creating these distances, it becomes, really, slow in a way, and it does not work well. So the computation cost is high. So whenever a new point is added, once again you have to, generate the distances between that point and each and every existing point. So that makes the computation cost high. So these are the few disadvantages, and of course it is sensitive to missing data. Now imagine just take two axes for a while, x and y. So when I say x equals to 2 and y equals to 3, you will go ahead and plot it on a graph. But when I just say x equals to 2 and y value is missing, so it can be literally anywhere. It can be on, x equals to 2 and y equals to 100, or it can be on x equals to 2 and y equals to 0. So when there is missing data, there is a discrepancy, and the model is really sensitive and it cannot properly handle this missing data. However, KNN can be used to fill the missing data, but if the missing data is present for the KNN model, then it is not good. So those were the advantages and disadvantages, and that's it from today's video. Thank you so much for watching.